Academy, and this is our first year implementing a new program at our school for math called Teach to One. And what Teach to One does is provide a personalized curriculum for every single student. Every day, students experience a range of different learning modalities, small group collaboration, peer-to-peer groups, independent learning zones where they're on the computer getting virtual instruction, as well as live investigations where they're exploring different math content and concepts, and 7-day task projects. I think the favorite one for the students is the 7-day task projects because it's multiple skills and embedded in real life situations. But every skill they see, they get to see it in all these different type of learning modalities. And every single day they take an exit slip, and based on that exit slip that determines their schedule for the very next day. So when we discuss differentiation and personalized learning, this is the most personalized you can get because every day, every schedule is different for each student.
So we come from Wilson Middle School. My name's Annika.
And I'm Hannah.
And we are 8th graders. And as 8th graders, we have our own laptops. We have Chromebooks. And we use many different programs to make projects.
We really enjoy using these, like Kahoot, which is like a game, iMovie on the MacBooks, and then different programs that we can use, and that makes it like learning a lot more interesting and hands-on, that we actually like want to learn.
We're part of a Storm Gears FRC high school robotics team based in Devens, Massachusetts, serving all of Middlesex, Massachusetts. And so we've developed a product called Steam Splash. And so what it is, it's a series of 8 one-hour sessions for students in kindergarten through 4th grade. And so it's hands-on activities that they can do.
Basically, what's really cool about this product is we have our own web portal where high school students from around the world can actually interactively mentor and talk with the students at taking the program, and actually help them out, help them get recognition badges on our website.
So a little bit about the reason why we started this product in the first place is that we're a part of an organization called FIRST, which stands for Inspiration and Recognition of Science and Technology. And their philosophy behind why they started this entire program is so that they can give back to the community and to teach and to make sure that all children in the world are exposed to science and STEAM and science and technology, because they're going to become the future leaders of tomorrow. So we ourselves, we took that. And we took inspiration from them when we were creating this. And our objective is to give children all over the world, and regardless of how much like income and status and any sorts of boundaries like that. And we want to provide an affordable kit to expose children at a young age to what STEAM is.
So this is a catapult, and so this is one of our activities that we've created in these sessions. And so basically, it's a simple catapult that can be made out of popsicle sticks and rubber bands, and so it'll be really easy for like a 1st grade student to make this with some supervision. We developed a web portal, so that way students that are taking these courses and doing these activities can dynamically interact with high school students and get feedback, earn recognition and badges and things like that.
So what we want to do is we create math music videos that help students to change their mindset about math.
We address many themes in Math with Matthew. We talk about STEM and encouraging females to join the STEM professions. We talk about mindsets like the fixed to the growth, trying to get a lot of people to think more of the growth mindset than the fixed mindset, which is I can't do it. Yeah.
And like a lot of people, they just, I hate math, I want to go on social media, but no, we need that future generation to be there for math, because math is very important. So this video is Girls Are All About That Math, and we're trying to show that girls, you should be in STEM, because don't be afraid you need to go in STEM because it's really important. And this is showing that, you know, boys of course are in STEM, but we want girls. So girls are all about that math.
We're from MIT, I'm Danielle. Arlette. I'm Rose. We participated last semester in a senior capstone class where you take something from ideation to full product launch in 4 months. We're from Red Team, and we developed Gravity, an interactive rock climbing game meant for kids. So it's like a treadmill but vertical. The object of the game is to touch the rocks that light up. You have 3 lives. If you touch the wrong rocks 3 times, you're out. We made sure it's like really safe, so we implemented a lot of safety devices. It's meant for kids. We want them to have fun. We make sure they don't get hurt on the game. So you put emergency stops. We made sure that they couldn't get pinched. And if they fall, there's a crash pad at the bottom. We made 2 prototypes. One of them was like 9 feet tall, and the second one right here is around 8 feet tall. We had to downsize because we couldn't get the first one out of the lab. We went through a lot of design changes. It was a very exciting experience, and we were very proud of what we ended up at the end of the semester.
We had a team of about 17 people. I think that you guys talked about like how the whole thing goes, so I'll just show you the product really quickly. So essentially what it is an attachment for a guitar that allows you to write music without actually having to write it. So if we hold this up, it's going to write it in tabular format, so that's going to show what fret I've played. So I'm going to play the first fret on the first string, and there you go, you get a 1. So if I play that a whole bunch of times, you get a bunch of 1s. Let's say I want to play a little bit lower, and that is the 6th. 4, 5, 6, 7, 8. And so this allows you to write music, save it as whatever, and come back to it later. The app is free through Thunkable. It got one of the best apps of 2016. Yeah, we just got that yesterday. It was pretty exciting.
At Beaver, we use a variety of different tools, some web-based, and we create different projects that are different than other schools to demonstrate our understanding of different projects.
Lots of times throughout the classroom we create coding projects where the teacher will give us a template and we can adapt it to fit to our specific project. And other times we will create, this is an example of an operation game that is anatomically correct, and this is a hologram project that we made in math class that we coded and used the laser cutter to make.
Myself and 4 other students created an autonomous robotics submarine which competes in a college level competition, and this helped us to gain a broad range of technical and problem solving skills and also empathy because we had to learn how to collaborate effectively on a very long-term project.
So my name is Corey Kozlowski. I'm the project manager of the Smart Garden at AHS.
Hi, and I'm Julia Jamie, and I'm a senior at AHS, and I coordinated everything that was biochemistry in the Smart Garden.
So this is the Smart Garden, or otherwise known as the food computer. This is a project by the MIT's Open Agriculture Initiative. What it is essentially a giant box that is maintained with sensors, actuators, and everything, so you can control the environment inside the box. So right now we're just growing mint for testing, but inside you can control like temperature, pH, like humidity, all these factors on this computer program. If you look here, all this is managed wirelessly from your desktop. So you can see there's readings of light, water, air, all these sensors, and what that does is it controls the environment for your plant. So say you're growing lettuce. Lettuce has a different environment than say strawberries. Like lettuce thrives in certain environments that strawberry doesn't. So you can upload a recipe for lettuce and it will grow lettuce to its best potential. It's like if you talk about a salad with the greenest greens, it will always grow that every time. And you can grow this anywhere. So places where they can't supply food, like food deserts, that's what the project calls it, you can provide food there without having like industrial shipping, for example.
And so basically the goal of the project is to eliminate any hands-on agriculture needs that you for growing the plants. So you would just see on the sensor and see what you need, and you would just add the required chemical. And like Corey said, it would help in environmental deserts and help other communities, and also it would reduce CO2 exponentially if this became a bigger thing in the future, because you wouldn't need like giant agriculture, like everything, like industries.